Okay, for this video, I'll be going through thermal properties of metal, tutorial question number 4. Okay, 1.5 kg of boiling water, that means this is my mass of boiling water, okay, and it's at 100 degrees, okay, was mixed with 0.5 kg, this is my mass of ice, of melting ice. That means the ice is actually at 0 degrees, right? If it's melting ice, it must be at 0 degrees. Boiling water, it must be at 100 degrees. But if I just say it is ice, then you cannot really say that it must be at 0 degrees. Okay, because it can be at -5, -10. But if I tell you it is melting ice, that means it is in the process of melting, it must be 0 degrees. So determine the resulting temperature. So let me set the resulting temperature to be X. Now, because there are two quantities here, one is boiling water, the temperature will drop, and the other one is melting ice, the temperature will increase. So I need to draw a heating and cooling curve. Okay, so for cooling curve, I'll be doing it for the boiling water. So again, temperature, then time. So initially it was at 100 degrees. Okay, then because it's mixed with the ice, it will then reach a temperature of X, which I'm supposed to find. Then for the ice, it is actually heated up by the boiling water, right? So it was initially at 0. Okay, so for ice, because it's melting, right? So it must fully melt first. Okay, and when all the ice has melted, then the temperature will increase. So this one is a slightly more complicated, right? But the final temperature will still be X. So let's go back to the cooling curve. So over here, it is actually water that is boiling. They did not say it's steam. It is water that is boiling, so it's at 100 degrees. So I'll be using CW. Okay. Now for the heating curve, over here I'll be using LF, specific latent heat of fusion. Over here I'll be using CW. So this will be 4200. CW will be also 4200. Okay, so we are actually using the specific latent heat of fusion for ice, changing into water, so it will be 0.33 times 10 to the power of 6. Okay, also need to take note that the mass over here is 1.5 kg. Okay, you need to use the corresponding mass. So over here, it will be 0.5 kg for ice, which after it has fully melted, it will become 0.5 kg of water. Okay, and the boiling water will be transferring its energy to the internal store of the melting ice. So the amount of energy that's being transferred by the boiling water must be equal to the energy being absorbed or being transferred into the melting ice, right? So because the question never talked about energy that is being transferred to the surrounding, so we take it that this amount Q equals to MC W, change in theta. So this amount is calculated like that, 4200, and I will use the higher temperature minus the lower temperature. Okay, so now this Q is unknown. I also have X that is unknown. Okay, then for the heating curve, I have, for the ice, it is Q equals to M L F. So after all the ice has melted, the water will increase in temperature, right? So I'll get MCW, change in theta. So let us put in the mass of ice multiplied by the specific latent heat of fusion, okay, plus mass of water resulting from all the ice that has melted, multiplied by specific heat capacity, and again we have X minus 0, right? So X is the final temperature. So X minus 0, we can actually treat it as X. So we have Q, which is unknown, and also an unknown of X. But because these two are the same, right? So I can form an equation 1.5, 4200, 100 minus x, and it is actually equals to this side, which is 0.5 times 10 to the power of, times 0.33 times 10 to the power of 6 plus 0.5 4200 times x. Okay, so now let me do my calculation. Just be careful when you are doing this, and you should get the final answer of x equals to. Okay, I've decided just to work out the next step. So I'll take this, so I'll get this, and then multiply by this, I'll get minus 6300x. So similarly, I'll solve for this plus 2100x. Now I shift all the numbers to one side, so I'll get 630000 minus 165000 equals to 2100x plus 6300x. Okay, and to solve this, eventually my x will be, okay, so solving this, I'll get x to be 55.4 degrees Celsius.